Okay, after we finish plotting the SPC chart, then besides to observe or to know that is there any problem, reject due to special cause happening in the processes, we want to know also the capability of our process. So with this SPC can help us to know whether our process is capable or not. So there are two purposes of performing process capability study. First, we want to determine whether process consistently result to meet the specification or not. Meet specification means no reject. And the second purpose is we can determine whether the process need monitoring or not. Because if the process is 6 sigma above, world class, maybe we don't need to monitor it much because the tendency to have rejection is very slim. So this process capability study will help us to understand whether the range over the natural variation, please find out what is the natural variation of a process occur is the result of the system common causes. What is the common causes? And common causes relates to the robustness. So with this process capability study, we will help you as manager whether the range over which natural variation in the process occur is the result of the system common causes. These are steps to do the process capability study. But I go straight to this formula. We can calculate the capability index. We have CPU and CPL for the lower limit, lower capability index, and we compare which one is the minimum, that is the CPK. Which one is the minimum between these two, that's the CPK. How to calculate the process capability upper and lower, these are the formula. And again, 3 sigma, because of the normal distribution chart for the SPC was based on 3 sigma. So we should have the upper limit, lower limit. We should know the mean. We should know the standard deviation. Then we can we are able to calculate the process capability. And when we have this CPK, process capability, this is what you should interpret. If the CPK is 1.25, means we are capable. If it is 1.33, highly capable. But if it is 2.0, it's 6 sigma, world class. If it is 1.0, means not capable. So we put 1.25 as a boundary here. Target 1.2, but if we get 1.5 and slightly above, it's good enough. But if it is far than 1.5 below, we have problem. So let's go to this. Let's look to this example. Overhead projector, the thickness of the component is specified to be between 30 and 40. There is a limit. They set the tolerance 30 and 40 only thickness. 30 sample yield 34 millimeter. That is the mean. And standard deviation is 3.5. But the limit 40, lower control limit 30. Calculate CPU. We use this formula. The lowest one is the CPK. Can you understand? This is your limit. This is your lower control limit. Sorry, your lower control limit is this one. This one. And this is your mean or standard deviation. You put into the formula. The lowest one is the CPK. 1.5, 1.25. But we got 0.38. What does it mean? Poor, not capable. So if we want to know further, because we know the limit here is 30 and 40. If I draw here, the limit 34, 30, 40. And you have the 3.5. So now you know that your process is not capable. You want to know your probability of rejection. Because you want to know you want to focus your loss. Because that is the reject. You have to live with this, but you need to improve. So how to calculate this? First step, we zeroize this. We standardize. 0, 40 minus 34, standard deviation 3.5. 30 minus 34. Calculate. Then what's next? What's next? What to do next? We do one by one. We want to know the area of this. This is 1.7114. So we use the table. Mm. 1.714, 17.14, 17.14, 1.7, 1.7, sorry, 1.71. 1.71. 1.7. 1.71. Somewhere around here.
9564.
7. So one, or maybe 1.72 lah. 1.71. 1.71. Okay. 1.71. 0.9564. Okay, that's the area for that. So this area is equal to
1 minus 9564.
Okay, the second one. This is the first part. Second part. We flip that. Otherwise, we just read minus 1.14 from that table. Try we flip this. So we want to know this area. 1.14. 1.14, 1.1. 0.9207. So this area is 1 minus 0.9207. 0.07. So we know the area already. So the reject, we want to know the percentage of reject. Probability of reject is 12.29%. 12.29%. Is it same? No. $17. Based on 30. Okay. So that's how to calculate that. So basically, this is how to calculate the process capability, and then using the table. Okay, let's I show you how we get straight away from this table. Minus 1.14, minus 1.14, minus 1.1, 1.14, 1.14. This is 0, 1.14, 0, 1, 2, 3, 4. 12.71. 12.71. 12.71. So this one is, the area for this one is 12 point, sorry, 0.14.
7 1.
Huh? 0.
1271.
1, 0 point,
Yes.
Yeah.
0 point
1271.
0.12.
71.
So it's almost the same, Same. Maybe I did a mistake somewhere here. Second step.
I think just now when Prof take the 1.14 to a wrong table.
Oh, wrong table. Okay, so you check by your own, but the method is the same. Maybe I read from the wrong table. It's okay. As long as we understand the steps. Okay. This is too bad, but if you use your own data in your company, maybe you get worse than this. This 1.38. At least we want 1.25. And sometimes when we do not have the subgroup, if your data is not arranged in subgroup, if we don't have subgroup, we can calculate based on the population, PPK. PPK is the process capability for the population. So we can calculate this way. Sigma and upper limit and lower limit as well. This is an example. We have the tolerance plus minus 0.002, and this is the mean. So this is our population n, and we have our x bar here. So we are required to calculate the PPK. So remember the formula, upper limit and lower limit. Same goes to upper limit, because we have this tolerance. So tells us the upper limit. And this is upper limit, lower limit. Uh, 2.998. So we have the upper limit, lower limit. And the mean, we base on yielded mean. This is our X double bar. We have the mean. And standard deviation for population. Look at here. This is formula for standard deviation. But there is a mistake here. Should be N. Standard deviation for population should be squared divided by N. So this is given already, 0.02. So we put into the formula, we got the PPK. Still, we based on the minimum value. So our PPK is 1.67. 1.67, 1.6 is more than highly capable. This is the PPK, population process capability. And Now, besides we determine the level of capability based on process capability or population capability, CPK or PPK, we can determine the sigma level based on defect as well, based on defect per million opportunities. When it is used, we calculate in the measure phase of the DMAC process in the Six Sigma, maybe use again throughout the DMAC process, define, measure, analyze, improve, and control in the Six Sigma and so on. So how to calculate this? We have to know the number of units we produce, how many we produce, and we need to know the number of defect opportunity per unit. What is defect opportunity per unit? For example, we have one component. Let's say this is the component. So you must know how many possible defect that might have on this component. How many possible defect that we might have for this component. So generally, the quality control have this information. That's why the quality control, the QC will check. Okay, they check this one, this one, this one. Only 3 parts. Okay, if pass this one, these 3, we consider pass. That is what we call defect opportunity. You understand what I mean? Opportunity for defect for one component. So normally the QC will check based on that opportunity only. So let's say if we have one part, one component that we produce have 10 point possibility of defect for each part. That's why they check 10 point. So the answer is here is 10 per unit. And then the third information, we should have the how many defect, the total number of defect. And then from there, we can calculate the defect per million opportunity. This is the example. For this toaster, we have 52 opportunity for defect, 52 point for defect. And we have 1,000 unit produced. And from the random, we detected 975 defect. So what is the sigma level? You try to calculate this. Defect, we have 975, 1 million. Opportunity 52 times how many units? 1,000 units. One eight seven five zero. So how to know the sigma level? So we have table for that. 18750. Sigma level table. Okay. 18. What was that? 1850.
18750.
18750. I write down here. 18750. Sorry. 18750. 18750. What is that? 18750 based on without shift first. DPMO 1875 is around
2.5. Eh,
18
2.
2.4, 2.3 to 2.4, right?
Yes, yes.
That was my slide. So it is 3.6, 18750. 18750.
3.6.
So we use with 1.5 sigma shift.
Oh,
So this one here, 1.8 something, 1.8. In between 3.5 to 3.6. Between here. 1.8, 1.8.
okay.
Sorry. 3.5 to 3.6 sigma. So it's good, it's better. Although it is not 6 sigma. Sigma level is 3.6. This is another example. Data entry form contain 20 field, sample 200 form. The evaluation found 500 defect in the 200 form. Calculate DPMO. This is data entry form contain 20 field. So form, borang, there are 20 blank to be filled. This is what they mean by this question. So 20 blank field to be filled by the people for one form means that's the opportunity. And how many defect we have? 500. So we calculate that based on that formula. 500 multiplied by 1 million divide by opportunity for defect 20 multiply by how many we have form. So that's the answer. So from there, we read from the table 1 to 5,000. 1 to 5,000. 125, 125. DPMO with sigma level. 125, 125. It's around 1 to 2.7 to 2.6. It's around here. It's around this one. 1 to 5, around 2.6, 2.7. If you want to know the exact answer, we have to interpolate. Same goes to this one. We can calculate the DPMO as well. So looking to this formula, how to reduce the DPMO? How to reduce the DPMO? If you look at to this table, when we have when we are at 6 sigma, we reject only 3.4. But this on the left hand side, this one by statistician. Statistician says when we are 6 sigma, we have 0 rejection for 1 million opportunity. But this is by Motorola. They put 1.5 sigma shift. Motorola says only 3.4 reject over 1 million produced. So when the DPMO smaller, the better. So how to make it small? So how to make it small? Reduce this one.
Reduce the defect.
Reduce the defect. And then what else?
Increase the
Increase the
number of sample.
number of opportunity.
Number of opportunity.
Means we reduce the defect, but at the meantime, we are more stringent. You understand what I mean? You measure more opportunity for defect, you have more inspection, you inspect more, but the rejection is reduced. So you can increase the DPMO. You understand what I mean? You got what I mean?
Yes.
That's how to improve the sigma level.